Hello, class 11th Kinematics, and we are studying vectors. So today we'll introduce vector algebra. So in vector algebra there are some mathematical operations: vector addition, vector subtraction, vector multiplication. But remember, vector division does not exist. It is a meaningless thing. So we'll start with vector addition. So in vector addition, there are two methods to show the vector addition graphically. First is triangle law of vector addition, and then parallelogram law of vector addition. Actually, both the laws leads to same result, but the difference is in between their applicability. Let us suppose uh, you covered a displacement A along this direction and then a displacement B along this direction. Then your overall displacement will be this. So we can say that when this vector is being added to this vector, then the resultant is the vector sum of both the vectors. That is, this will be the A plus B. It means if two vectors act along the sides of a triangle taken in order, then the third side taken in opposite order will give the vector addition of both the vectors. That's so simple. So it means if we join head of one of the vector to the tail of other vector, then the third vector starting from the tail of first vector and end at the terminal point of other vector, that will give their vector addition. So this is how we explain triangle law. And as I have given you the example of displacement, so yes, example of displacement is very well understood by triangle law. Then why do we need parallelogram law? So again, the difference is in between their applicability. So let us suppose there is an object A and we are applying force A and B on it, then where will be the resultant force? So first draw a parallelogram, and then this diagonal, which is also originating from the same point from where these two vectors are originating, that will give their vector addition. Alright, so in parallelogram law, we say that if two vectors forms the adjacent sides of a parallelogram, then the corresponding diagonal, which is also originating from the common initial point of the two vectors, then that diagonal gives the vector addition of the two vectors. Alright, so actually both the rules are otherwise same. because you can see this shape here and this is similar to that. Just the difference is their applicability. If angle between A and B is theta, we show the angle between both the vector like this in triangle law, because line of action of A is along this way and B is along that way. So this is the angle between them. And here in parallelogram law, line of action of A is this, line of action of B is this. So this is the angle between them, theta. So the resultant, this A plus B, we'll call it R. Here also R. So resultant, and see, I'm taking its magnitude only, because this is we can obtain this result by just geometrical manner. So that is why it is just the magnitude. So if we are interested in magnitude, we can find it like this: a squared plus b squared plus 2ab cos theta. In both the cases, we can apply this formula. Now see, uh, let's check this with uh, with an example. I'm taking a numerical problem where vector A has magnitude 12, vector B has magnitude 5. And see, if both the vectors are in same direction, let theta between them is 0 degree. So this is 12, this is A vector, and this is B vector. Both are in same direction. So graphically, or we can say geometrically, we can say that both will be directly added. We don't need any formula for that. They can be directly added. Resultant will be simply A plus B equal to 12 plus 5 equal to 17. Why is the need of this formula then? Or if the angle between them is 90 degree, then A is this, B is this, so their resultant will be obtained by Pythagoras theorem. So R is equal to root of A square plus B square, so it is 12 square plus 5 square, which is root 169, which is 13. It's totally geometrical interpretation. And if angle between them is 180 degree, means one of the vector, like if it is displacement, then it is going this way and then it has returned back up to this distance. So we can directly subtract them and the difference will be their resultant. So R is equal to simply A minus B, that is 12 minus 5, that is 7. But what if there is any other angle other than 0, 180 or 90? Then we must go for this formula. And let's check it out. And I am now taking different cases: 0 degree, 30 degree, 90 degree, and 180 degree. So if we apply these values here, then the resultant is root A square. A square means 12 square, B square means 5 square, plus 2 into 12 into 5 cos 0. Cos 0 is 1. So this is 169. This is 144 plus 25 plus uh, 120, which is root 289, which is 17. And this is what we obtain directly. It means if the vectors are in same direction, angle between them is 0, we can directly add their magnitude as we do in ordinary mathematics. But if angle between them is 30 degree, okay, before that let's move to 90 degree. So here r is equal to, I'm directly putting the values, a square is 144, b square 25 plus 120, but cos 90 is 0. So entire this quantity will be removed, only 169 will be there, 13. Yes, of course, that's what we obtained from the geometry. Okay, here remember cos 180 is minus 1. Um, okay, so r is equal to root 144 plus 25 and minus this time, because cos 180 is minus 1, so minus 120. So here it is, it will be 169 minus 120, that is root 49, and that is 7, and this is what we obtained there. So these formulae are totally, I mean, this is a comprehensive formula which will be applied everywhere. Otherwise, it is totally geometric uh, in nature. See, in fact, this formula is derived by the knowledge of geometry only. I'm going to derive it later, but here I am telling you the applicability of this formula. Root, this will be 144 plus 25 plus 120, and cos 30 is uh, root 3 by 2, I guess. Yes. Okay. We can't do anything with this. 169 plus 60 root 3. We can end this discussion here. The bottom line is uh, vector addition not only depends upon magnitude but also upon the direction. And vector addition varies from just the addition of magnitudes of both the vectors to difference between the magnitudes of both the vectors. You can see there is only the difference between the angle and nothing else. So what we can conclude here is that this a plus b, vector a plus b mod is always less than or in one case equal to mod a plus, or I can directly write it a plus b. This is actually, I have taken mod. I can write it like this also, but that is too time consuming, so I'm directly writing it a plus b. Okay. Another thing means the vector addition of two uh, terms, two values, two vector values will always be less than the addition of their magnitudes taken separately, as we have seen here. If both are in same direction, we can directly add their magnitudes. But it is not all in all cases, only when they are in same direction. So this a plus b, that vector addition, can have this value as maximum value, and this a plus b means the vector addition can always be greater than or equal to, means not less than, their difference. I am putting mod here in order to avoid the negative sign if it would come. Then if we combine these two results, we can write it like this: a plus b mod is less than or equal to a plus b, or is greater than or equal to a minus b mod. Keep this thing in your mind. Okay, in short, I would say that if a vector has magnitude 12, other vector has magnitude 5, then their vector addition cannot exceed the value 17 and cannot have value less than 7. But their vector addition will be in between these two values, including these values. Remember that. So this is how we do vector addition. But this is not all, this is not only the case. There's another way by which we can add them, and quite easily. And that method is, if the vector is given in the form of its components, means if vector a, remember the difference, I try to identify the difference between both ways. We are familiar with this representation of a vector where ax, ay, az are its component along x, y, and z axis. I, j, k caps are unit vectors along x axis, y axis, and z axis, which represent their specific directions. So if b is also given as bxi cap plus byj cap plus bz k cap, then their vector addition a plus b will be given by ax plus bx I cap, like uh, we do in algebra, adding like terms, ay plus by j cap plus az plus bz k cap. And if we want to find its magnitude, then we have done these things in previous video, so we know about it. So its magnitude will be ax plus bx square plus ay plus by square plus az plus bz square. Both things look pole apart, but trust me, if we are if we would able to express these vector a and b in terms of this or that, we could be able to figure it out that they are leading toward the same results. So keep both the things in your mind. If vectors have been given in this way in component form, then you can directly add them. But if only the magnitude is given, then we can use this expression.